Thanks a lot for joining. I really appreciate it. And I'm really excited for today's session. We have Prasad here with us and Matt. Prasad, Matt, how are you doing? Let's start with Prasad.
Very good.
Hi, Kunal. How are you?
Yeah, doing good.
Good. Thanks for organizing this. We're all excited to talk about different things, what we are bringing, and experiences in disaster recovery. So it's interesting.
Nice. Looking forward to chatting with you. How's it going, Matt?
I'm great. Looking forward to having this conversation. It's been a big part of my career in the last half decade or so.
Yeah, and for those of you who don't know, these two folks, they have extensive amount of experience with managing data, and especially when working with K8s. So today we're going to talk about Kubernetes disaster recovery. We're going to talk about KubeSlice and some amazing projects, and preventing major data losses. Working with large amount of data, making sure that you're all up to date. That's what we're going to discuss. You can also share in your questions in the chat. I see a few, close to 100 people are already live, which is good. So I'm expecting nice questions. If you're not live, this is being recorded, so you can watch it again as many times as you like. And I'll leave all the links in the description as well, so you can join the Slack channels and also connect with the guests over here. All right. So yeah, let's keep the momentum going and asking your questions. Happy to answer those live. And no, this is live. Someone is saying it's not live. No, it is live right now. All right. Appreciate it. Thank you. And before we get started, let's do some introductions. Matt, would you like to introduce yourself? And then Prasad, I believe you can do it. And then you can share your screen I believe you have a presentation.
Sure. Matt LeBlanc. I am a systems engineer here at Avesha. I live in the Boston area, where I've spent a lot of part of my career working in data center technology, from storage at EMC, and more recently, in the last 3+ years, I've been in Kubernetes data protection, and most recently moved over to the Avesha team.
Thanks, Matt. Hi, everybody. My name is Prasad Dorbala. I'm a co-founder and chief product officer for Avesha. My experience has been operating large-scale infrastructures, be it a SaaS provider or managed services for disaster recovery and others. As we see the industry trend, data on Kubernetes is increasing. It is year over year, it is growing about 40%. So you can see that a lot of people are bringing data onto Kubernetes. Previously, it used to be more stateless workload, but now stateful workloads are coming over. And one of the key important factors is, how do you protect the infrastructure? There will be lots and lots of failures for various reasons, not necessarily internal, but also external. So how do you make sure your business is up and running? So loss of any availability of infrastructure or services would impact revenue from a top-line revenue from an enterprise standpoint. Not only that, it would also impact customer experience. My CEO used to say, "Don't let me come onto the front page of any newspaper because we lost service." So that's the reason why it is very important to understand the behaviors with respect to recovery, and as well as how do you protect your infrastructure. That's what we're going to talk.
Amazing. Well, thanks for sharing, Matt and Prasad. I believe you can share your screen. So you have some cool demos to show.
I'm going to start sharing the screen, and let me pull this. I would let Matt start.
Sure. So today we're going to talk about Zero RTO. We'll cover what a RTO is in just a moment. So what is an RTO? It's really about time. So there are two different, there's recover point objective and recover time objective. And basically your recover point objective is to the point of the last backup, but your recovered time objective is how long can you tolerate getting back to. So really there are two different moments. So when was your last backup versus how long does it take to get your application back up on its feet? Next slide. So why are we talking about this? Well, there are a few different reasons that why we need to make sure that we have data protection. First of all, there is customer experience. If your application is down, your customers may not experience, might have a positive user experience. For example, this is a recent story, a large American auto manufacturer, they have a application that you control your car with, and allows you to start your car, start the car, turn it off, lock the car, that type of thing via their app. And apparently their application goes down on a regular basis and they need to get back to a last good point. So it does impact customer experience. As a owner of one of those vehicles, I have experienced when it doesn't work and it's the winter time and I can't start my car. Another user experience, which maybe some of you can relate to, would be a few months ago, there was a problem with the traffic control system, which is ancient, and that's another story. But the traffic control system was down. And the reason it was down was there was I believe there was a bad restore on from a backup, which comes down to another point of make sure you practice your backups, make sure you know you're able to get back on your feet. And obviously, there's also the idea of you could lose data if you had a bad actor. I'll give you another example of that one. A few years ago, there was a employee of Twitter who was quitting. And just before he left, he went and deleted the real Donald Trump's account. So obviously, a backup allowed them to get back up on their feet. But, between user experience, bad actor, and what I'm going to talk about right now is compliance. We also need it for regulation purposes, and SOC 2 is a really good example. So there are some 5 basic criteria here. You can hit the next animation there. And it really talks about a few different basic components. Security, making sure that data is data is behind firewall, you have intrusion protection, and it is secure. Confidential, so make sure it is encrypted, as well as proper access controls and firewalls. Available, that comes down to making sure you have a DR capability, the ability to go back in time to recover your application, as well as processing integrity and privacy, making sure all that data is secure and available. So that is the reason why you need it. And for SOC 2, if you are not in compliance and you are audited, as Prasad was talking about earlier, it also means that in addition to revenue loss from being down or bad customer experience from being down, regulation may also impose fines on you. So not only are you losing users, customers, you are losing your reputation, potentially losing revenue, and now you're going to incur fines. So there's a lot of good reasons for data protection. Next slide.
Now, I just wanted to add here, most of the SaaS providers, when you want to impress upon the customers that you are a SaaS solution, the very first thing enterprises would ask you is, show me your service organization control, right? What controls do you have in place? So that, like Mac described, what's your access privileges, so that, in your employees, who is logging in, who is logging out, what is the audit process? Not only that, confidentiality, integrity, and availability. So these are the auditable items which are audited by the third party, which is the auditor, and they give you an attestation that you are actually have controls in place. You're able to mitigate the risks and then be able to be available. That is the certificate which every enterprises would ask for them to actually sign up for a service. So it is very, very important for the internal engineering team to be geared up whenever we put up an infrastructure to be more SOC 2 compliant. So, Matt, go ahead.
There's a comment. If you can explain RPO and RTO with an example.
Okay. Recover point objective or recover time objective. Can you go back to that other slide? Thank you. So our recover point objective is how far back do you need to go? So you need to go back, say, 15 minutes to an hour. That will be your last known good point. But just because you're able to go back 15 minutes, it doesn't mean you're going to be recover immediately. There's going to take some time to recover, whether you're moving data to recover your PVC, your chunk of disk that your application's using. It will take time to move that data, and it may take time to redeploy that application on the other side. So recover point will be your last known good backup, let's say 11 a.m. But your recover time objective may be much later than that. So you did your backup at 11 o'clock, but you know it takes time to get the bits moved across the wire and time to redeploy that application. So your RTO may be an hour, but your RPO may be 15 minutes. So it all depends on data movement and how long it takes to deploy that application. Prasad, do you have any more to add?
No, I think, as you rightly said, right? If you have a database and then you're doing a checkpoint on your data, and the data is resident on your disk, and then that gets copied over to a different location, that is the time frame. It is when you do a checkpoints, that is your recovery point, right? And then be able to recover up to the known good state from your application consistency standpoint. Recovery time objective is, let's assume you're not active, you're an active passive or active standby. If you want to bring up your services, how fast do you bring up the services? The services can reach to your application data and then be able to serve. That is your RTO, recovery time objective, right? So I just digging deep into that, right? Enterprises, by and large, have hundreds and hundreds of applications, right? So typical use cases are, what are the customer facing or the critical applications? You need to first get an inventory of what applications do you have, and not all applications have the same criticality of being available, right? So beyond the technology, there is also a process when you declare this disaster, right? So typically, some of the organizations have a restriction with respect to where the geographic location is, right? So SOC 2 also describes whether your primary site to a recovered site, is it how many miles away, or is it? So why is it important? Is that, let's say you're in a data center, and then you have a dual feed for your power, but something happens to that area in the geographic area, and then you lose both the dual feeds of power, and then obviously you would have backup by diesel or something like that, but you drain out. And then what happens is you want to go to a different region, not in the same region, but a different region, so that you don't have that impact. So, but when you are moving from one region to another region, is it that all applications need to be needed, or what are the critical applications are needed to be active to serve the customers? So there is a whole slew of inventory which people do, what are necessary for real time, near real time applications. There could be some which can be like, back office kind of an applications, which can have some toleration with respect to when they come back up. Or there could be a cold start saying that, hey, these things can come an hour later, but I want to make sure that the real-time applications or which are customer facing need to be there. So for that's the strategy which you need to have in order to get your DR plan in place, right? Not only this, but there is also incident response management for telling the customers this is happening. So there is a lots of happening, but we are trying to focus on technology at this point. If you were to have active, right? As we call it CDP, continuous data protection. So continuous data protection is the RPO is almost near real time, right? You want to have synchronous replication of data from site A to site B, and thanks to Kubernetes and the world of containers has helped us a lot to scale applications quickly. So previously, before containers, you would have to bring the servers up and applications up. Those are that used to take a longer time. Now, in this container world of Kubernetes, people are trying to say, can I really have a zero RTO, right? As in, you don't miss a heartbeat from a customer standpoint, and then be able to scale it. That is what you would need to do with respect to active. But you don't want to do it for the entire infrastructure of 300 or 400 applications. You want to just do it for the critical applications. Some of them maybe in a hot standby where they have the tolerance to be available within 30 minutes, right? Say, for instance, when you are metering certain services and then metering that services are monthly billing, although you have telemetry of what is utilization, you don't have to really bill it immediately. So those kind of applications, like what we call it back office applications, can come back a little later, right? So if there is some analytics kind of a thing which you would need to do it, monthly basis or quarterly basis, those things need not necessarily be as real time as needed. So they may come up with a cold start. So each one would have a different strategy, right? So where you do replications. Remember, data is the new oil, right? So every application relies on data, and data is the key factor for the recovery aspect, right? So how do you replicate that data is the most important strategy with respect to DR, right? Um, in the world of Kubernetes, right, you have lots and lots of objects. Right now, when you bring the services onto Kubernetes and data onto Kubernetes, you store this data in persistent volumes, and then you do the claims to make sure that your application take the persistent volume. One important factor in Kubernetes world is all the persistent volume. You can virtualize it when you are inside a cluster, right? When you want to go across clusters, because you want to have this dependency of across regions, now how do you replicate the persistent volumes so that you have the data consistency in a different location? That is one important factor you need to consider. When an application comes, you want to have whether it is in MTLS for your service to service communication, or whether it is a different type of certificates which you use. Those are all the things which you have to do. So we used to use a statement in when we are recovering: before you do any good, don't do any harm, right? Like internal threats and external threats are very important from a perspective of any operations from a security perspective. So RBAC rules, RBAC policies, network policies, all those things are important even in the recovery side, right? So how do you propagate those things? And then how do we make sure that when you go to a different site, the RBACs are maintained? So those are all important. Now, in Kubernetes, it gives you the freedom to create your own custom resources, right? You take third party controllers, and then you deploy it. Now, when you go into a newer site, how do you make sure that your CRDs are maintained, the custom resources and state associated with the CRDs are maintained? Those are all things which are very important, right? So similarly, ingress rules and services and tooling, right? You got to know insight into what is happening. So that those are also important for you to consider. Matt, you want to take this, or should I?
You can go with this one.
Yeah. So as I was talking to you, the question of snapshotting for your PVs are based on your recovery time objective and recovery point objective. You could do synchronous replication if the sites between the two production and recovery site is less than 10 milliseconds. So if it is farther than, if your tolerance for your application is a little sensitive, but you cannot tolerate 80 milliseconds or 60 milliseconds of data, then you would have to do snapshotting and synchronization. But that is one aspect. But scaling, that defines an RTO for you. But RTO is the user experience, right? How do you make sure that it is there? So infrastructure, the scaling of that, the deployment of your applications, RBAC policies, all of those things are important for you to make that recovery much more smoother and easier, right? That is what is important for any kind of a framework. Matt?
We're going to take a little step back. I did see in the comments about one person asked what was Kubernetes, and I'll simply state that Kubernetes is the next generation platform for your workloads. So basically, if we started off in the world of let's just go back one or two steps back to virtualization. Everyone moved their operating systems and applications into a VM. We moved into the world of containers. Docker was probably the most well known, and Kubernetes is really ultimately the winner of the container wars, shall we say? And when Kubernetes first started, everything was believed to be, or everything was mostly ephemeral, in that there was no standard way of accessing your storage. So there are a few misconceptions here. So all Kubernetes workloads are stateless. That's not correct. Because of the CSI driver that was available, and I'll talk about it in a minute, it basically allowed for saving state to your disk, whatever disk you're using. Misconception number two, data protection is not my responsibility. We are all responsible for that data. So if you were to deploy a application that has state, then you need to make sure that you're aware to protect it. We talked about why: customer experience, recoverability, regulation, and revenue loss. And misconception number three, I don't have any stateful apps. Are you sure? I've had this conversation with many people, and maybe it's just the terminology of stateful versus stateless, but and the history of believing that Kubernetes did not have the ability to have state to be carried. But things have changed. So I will point out that the CSI drivers, that's container storage interface, they were introduced in late 2019. And about a year later, they added the CSI snapshot functionality. Once that was available to the public, that allowed stateful apps to be deployed. So rather than asking my customers about their stateful apps, I'll rephrase it. Are you running a database in your cluster? If you do have a database, you're running stateful data. So some examples: Mongo, Postgres, Cassandra, MySQL, Elasticsearch. Those have an active database and they reside on the PVC, persistent volume claim. That's the chunk of disk that is reserved to that application. So we now understand that not all Kubernetes applications are stateless, because of all of those applications or databases. And they're all available on the CNCF website. There are many projects out there, and many of them are databases. Next slide. So how does KubeSlice help? So we can help with that recoverability. So we talked about those 5 components earlier. It needs to be secure. So what KubeSlice does is it allows you to connect securely, timely, and reliably complete your replication across your clusters. So,
Matt, so hold on a second. There is a question. What does stateful mean here?
Stateful means that you are saving the state. So, for example, stateless. Let me talk about that. So, if you have an application that is stateless, and basically it's processing something, and I will give you an oversimplified example, in that your app is going to go grab some data, say from an S3 bucket, and it's going to process that application and hand you the answer, right? The answer is 42. It's on your screen. You turn your computer off, it's gone. It is not saved. It is stateless. You got your answer and that's it. End of story. A stateful is a application that is keeping that data. So whether you're talking about a spreadsheet on your own computer, or you're talking about a database, you are saving that data, because the intention of a stateful application is you're going to write to it, you're going to read from it, you're going to update it. So that is pretty much what what is the difference between stateful and stateless. Thanks, Prasad.
And to embellish more to what Matt said, there is a distinction how Kubernetes does with respect to stateful and stateless. If you're look at a pod name, stateless pods are pod name, service name, da da da, and then some hash key which you're associated with it. So the identity is ephemeral, right? They come and then go, and then it can be anything. But whereas stateful workloads have a certain set of a sequence which they need to bring in. So when you are working with large scale databases or any kind of a application which actually turns up databases, they're all stateful. In fact, their identity is maintained when you shut it down and then bringing back up. Their identity is also maintained. So that is important to understand where the stateless workloads and stateful workloads are.
There is a question up on the screen I would like to address. It says, is there any solutions for efficient data backup in K8s Kubernetes that is hosting Postgres on a persistent volume? Currently, we are using external VM for hosting the DB. There are many data protection players out there. One of the challenges in all of those solutions is they're really focused on each of the clusters. So it is all backups are done on a per workload, per cluster basis. So if you want to back up your PostgreSQL on cluster 1, you're going to log into the backup console for cluster 1 and say, let's back up PostgreSQL. And then you have a different management solution over on the other side. That applies to all of the solutions out there. There's one free open source project called Valero, which is funded by VMware, and that will allow you to command line do backups. But there are many other backups out there. The challenge is you don't have a single place to manage all that. And again, that is kind of where KubeSlice can come in to help and provide that means of securing your data through a replicated fashion very quickly.
Yeah.
Prasad, do you have anything else to add?
Yeah, no, I think, in fact, one of the important factors for replication, Postgres by itself gives you the ability to actually do the wall file movement and different things, and then you kind of do it. So what is happening is, as you all know, Kubernetes is always centered around cluster boundary, right? When you want to do disaster recovery and then you want to do multi-cluster, that is where the challenges are going to be. So KubeSlice is a platform which enables all that replication so that you can turn on the Postgres active, and then backup Postgres, and then move the WAL files over through KubeSlice. And I think if somebody is interested in reach out to us, we'll show you how easy it is to actually do a Postgres replication across multi-cluster using KubeSlice. That's something which we have used on this platform much easily. A little later, I will show you a demonstration of how we do replication through MongoDB. It's a similar concept, but I would also display in our demonstration. Right.
We have another question, Prasad. Why does clouds like GCP, AWS have their own DR solution for GKE and EKS cluster? Actually, most of the cloud providers out there don't really have a solution. Their approach, they may have something for their EC2 instances, but for EKS, AKS, GKE, the responsibility for the data is on the end user.
Yeah.
I'm going to repeat that again. The responsibility for the data is put on the shoulders of the owner of the data, the user, right? They'll help you with that managed service Kubernetes cluster, but they're not there to protect your data. This is very, very similar to, say, Office 365, where, yes, Microsoft will replicate that data across your laptops and from the cloud, but the end user is responsible for that data. So if I delete my data, I'm responsible to get it back, or my employer. Hopefully they have some solution in place. So that is why there really are no built-in solutions, and there are no, well, aside from the one we're going to talk about today, there are no solutions for going across clouds. So if you wanted to have a application that was running across AKS and EKS and GKE, that is possible, which I believe Prasad's going to show you later on today.
Yeah. And another thing, the trend in the industry is people don't want to have vendor lock-in, right? So while it is important to jumpstart a lot of different things in the cloud provider solutions, but people are trying to the whole motion for the CNCF is trying to make it cloud native and Kubernetes native. If you were to do something in the Kubernetes native, then you have to build your own tools, or you need to use some tools which are out there in the market to be able to have that happen, so that you don't have to get vendor locked in with the solutions which are done by the cloud providers.
All right, so back to our deck here. So we were talking about security, and KubeSlice creates a non-routable connection between your namespaces in each of your clusters. I'm going to repeat that again. Creates a flat network that is secure, open VPN tunnel, and allows access only to the information within namespace A in cluster A and namespace B in cluster B. So that allows for that replication that Prasad was talking about. From a confidentiality standpoint, it is non-routable, and you have the ability to have very granular role-based access control, so you can limit access to those namespaces. It allows for performance monitoring. We can be able to know that you are within your response time that is necessary. If we have a synchronous requirement, I believe 10 seconds was the maximum required for that Prasad had mentioned earlier, and otherwise it's really going to go into an async type of scenario. Process integrity. KubeSlice is able to do monitoring and logging, so you know exactly what is going on, who has access to what. And then finally, on the privacy side, instead of the only way to connect two clusters without KubeSlice is really to connect them fully. So if cluster A was connected to cluster B, it means that everyone or everything inside of cluster A will be able to see all the objects within cluster B. What KubeSlice does, instead of going to the north-south route, basically going over going out of your cluster over the internet and back down into your other cluster, we're going to go this east-west passage, which basically allows for a point-to-point tunnel between those namespaces. Prasad, anything else to add, Matt?
I think Nimish was talking about it would be useful if we have multi-tenancy architecture, which client has their own databases. In fact, Nimish, as you can see further down when we go into the demo, this concept of slice is exactly that. Where we are building networking across clusters in a single cluster or multi-cluster, and then grouping namespaces to create a tenancy. Tenancy can be a team, or tenancy can be a set of applications. And that particular network solutions, which we are, if I have time, I will show you that network solution, which is a flat network across. It's like a virtual cluster across multiple physical clusters, and then you can do multiple virtual clusters inside the same cluster, as fleet of clusters. So that's the construct which we have built with KubeSlice. This is an open source project. You can go to github.com/KubeSlice, and then you can try it out. And it is much easier to put certain namespaces on KubeSlice and then create a network service on that. I hope you addressed it there.
I think we can go to the next slide. And that is it. So that leads us to the demo that Prasad was talking about. Why don't you explain how we have this set up here?
Yeah. So let me just share. So hopefully my token did not expire. There we go. I know that I expected it. All right. So don't worry about the trial license. I'm just using this thing. So this is KubeSlice in action, right? This is an enterprise version, which I'm showing you, but there is an open source version. You would not see the pretty UI, but most of the functionality is out there. Where the way Kubernetes KubeSlice works, it has a controller, which is essentially using it can be a cluster by itself, or it can be a part of a cluster, and then you register a bunch of clusters into your framework. Right? You can register very simply by adding the manual option by naming the cluster, and then put the kubeconfig, and then hit import the cluster. It automatically registers. What they mean by registering is it actually deploys a controller. We are an operator model, so that you don't have any kind of a drift and all that stuff. So the operator gets installed, and then you can actually use that operator to create a bunch of slices. Slice is nothing other than, let's say, if you manage namespaces. So MongoDB slice, I said it, right? So right now, MongoDB slice I created saying that there is a MongoDB namespaces in worker 1, worker 2, worker 3, which is essentially, when you look at it, there is a cluster in GCP, there is a cluster in AWS, and there is a cluster in Azure. In this case, I used multi-cloud scenario, but you could use it for the same EKS, or you can use it for your on-prem solutions. We support edge, data center, and all clouds possible. Distribution is irrespective for us. Any kind of a distribution, you have a Rancher distribution, an OpenShift distribution, you can use that, right? So, if you register, you can see here, right, when you go to manual mode, different types of clouds you can select, right? Whether it is Azure, Edge, GCP, Kind, OpenShift, Oracle, Rancher. All these clusters can be onboarded onto your controller, and then now what you need to do is you create a slice by adding a bunch of things with respect to add slice. You can create different sets of namespaces and all that stuff. So I'm not going to do that for now in the demonstration purposes, but it is from a single pane of glass. You can be able to manage the clusters from a topological view. How many, say for instance, I talked about, right, Azure to AWS, uh, right? It can be 2 milliseconds because it's all, both of them on US East. So, but if it is 60 milliseconds from US East to US West, that is somehow, you want to see whether the strategy for the replication, is it a continuous replication or is it a synchronous or an asynchronous replication? Some applications can survive that 60 milliseconds. This is speed of light, right? You can't change much from a standpoint of physics. So you can see how clusters are communicating, insight into as you can see from a worker two. Worker one is very close to each other, so that's the reason why. But other one is different. You can manage, you can see the health of all the cluster slices, and each and every component inside it. You can also manage resource quotas, yeah, right? So Alex, what is milliseconds time mentioned mean? So it is the latency between two endpoints talking to each other, is the amount of time it takes for the round trip. That is the milliseconds. It is the delay between the two clusters. That is what the milliseconds definition here on this one, right? So you can have the resource management and all that stuff across multi-cluster. So why am I showing you all this is I created a slice, in between three clusters, right? And then I discovered services across all these three clusters, and then created a network services, which is a flat network. So with a address scheme of 192.168.16.0.0. So that way, what happened is that now each cluster can have their own pod cider. There is no conflict. We create an overlay network on top of it, right? And then you connect them by having to see all of them. You can add more clusters as we go along. If there are more clusters, you can add more clusters, or you can subtract clusters easily through a single pane of glass across these things, right? So I did this, right, and then deployed MongoDB. In fact, if people are familiar with Lens, I'm going to show you Lens, right? So this is the AWS cluster. If you see the namespace, MongoDB, MongoDB, there is so pods. There is a MongoDB set 001 in the cluster, which is in AWS. So when I go to this is GCP, or no, this is Azure. If you go to Azure and then look at MongoDB, there is a set one, which is, so if you remember, we were talking about what is a stateful set and a stateless set. Any database, all of them are stateful sets. So that's the reason why when you see the pod name is going to be the name as defined by what you wanted, right? So when you go to GCP, right, I'm going to show you that the namespace MongoDB. So there is a replica set too, and then MongoDB has an operator which is coexisting with all the databases, and that actually makes that if the database the lifecycle management of it. So that's the reason why the MongoDB 1 is primary here. MongoDB 2, which is running in Azure cluster, is secondary. MongoDB 3, which is essentially in GCP or something. So literally, if one of the site goes down, all of these things will become primary. And when the site comes back up, all the replication happens So you can see processes, from a real-time standpoint. Let it generate the data in 2 seconds. You can see all the transactions are actually going across these heterogeneous Kubernetes clusters across clouds, and then being able to replicate it, measure the metrics which are going across, what is the network latency, what it is seeing, how much is the throughput, all that stuff. Now, literally, this became the DR scenario where if any site is down, immediately the other site, picks up, and you have 3 different sites. I mean, this is a bank solution where they wanted to have not just a single site as a recovery site. They wanted to have multiple sites, and the multiple sites were actually read only, whereas one site was a write only. So that's the environment which we have demonstrated, and they are testing it out on KubeSlice. So all of these things are very simple, because across clusters we are able to export services. I don't know how many of you are familiar with SIG multi-cluster service export, service import construct. That SIG multi-cluster has defined MCS API. MCS is multi-cluster services API. So that API is what is implemented on Kubernetes, on KubeSlice, which allows you to export all different services from different locations, and then make sure that your MongoDB is, DR proof. One side goes down, like for instance, if this, like for some time back, I made a change, so this became primary, 0 became secondary. So and then this will come. So that kind of replication is easily possible in on KubeSlice. So the DR environment cluster will be directly connected with the live environment cluster all the time, or only during disaster. So Sajal, the question is, do you connect all the time, or do you not connect all the time? I think it goes back to the presentation which I shared, right? If you look at it, so if you want to have active near real-time RTO and near real-time RTO, then it is synchronous replication near real-time. It's always connected. But if it is like a hot standby, uh, then it is asynchronous replication. You're taking snapshots and then doing that. But if it is a cold startup, right, then it is a restore from backup. At that time, you don't have to have any active scenario, but you redeploy and then make them come up. Right? Did I answer that question?
There was another question. Please address the Zero RTO bit. How do we enable Zero RTO?
So what we are enabling is KubeSlice is a slice across multi-cluster environment, like for instance cluster 1 to cluster 2 to cluster 3 and all that stuff, right? So if cluster 1 goes down, and then you have the deployment spec already in cluster 2, you auto scale using HPA. And that way, what happens is you have your HPA. So initial hiccup, as in you have minimal, the min to be like 5 or some based on your service, and then max is when you actually grow. And then you enable the cluster autoscaler. So as and when the traffic is coming up, the nodes get deployed. So very important thing to remember, from the container to the world of previously we used to have servers per applications per servers, but now in the container Kubernetes way, the application can be in any of the server pool, right? So you do need to take into consideration, if you have node affinity and all those things maintained, you need to make sure those labels are there. But once the node pool brings up more nodes, and then HPA kicks in, and then it grows. So as long as you have minimum capacity from a HPA standpoint, and then put that, then it is literally zero RTO.
Prasad, we do have a few folks that are probably newer to Kubernetes. Could you explain the concept of HPA?
So HPA is horizontal pod autoscaling, right? So when you have a replica, you can have the same service and then deploy it in, so how many replicas you want to have, right? Replicas are 3 in number, 0. It's, if you don't want to have any replicas, it is 0. So Kubernetes spins up those pods on demand based on various metrics. One metric is CPU utilization and memory. The typical HPA, I mean, in fact, we at Avesha, we have, RL, which is reinforcement-based learning HPA, which actually looks at service availability, SLA, and as well as the service latency, and then we grow. So the grow is Kubernetes scheduler will automatically spin up the pods if the CPU is starving or memory is starving, so that you can have more copies of these services, and then you can serve more traffic. That is HPA.
So that's Kubernetes' ability to scale up and as well as scale back.
Scale down, right? Yeah.
We also have compiled some of the questions. I'll put them on the screen.
All right.
Once we're done with the...
So I'm going to stop sharing and then probably use. All right. What level of technical expertise or knowledge is required to implement and manage KubeSlice efficiently? Our goal is to make sure it is as simple as possible, right? So I think Matt keeps asking me, "Can my grandma do it?" So that is that's our mantra. Make sure. Can we make sure that we can have a small, the people who are not as proficient as Kubernetes be able to do it? So we have automated a whole slew of things and effectively managed everything through a controller. And by the way, this is rich UI is built thanks to our marketing team, who have spent a lot of time thinking about how to usability aspects. Enterprise is point and click and then do it, and that's how we do it. Should be aware when implementing KubeSlice for disaster recovery. So I come from where regulated industries on many things. I, in fact, did FedRAMP and other things, right? So all of these need disaster recovery, whether it is SOC 2, FedRAMP, HIPAA compliant based stuff. And so as Matt described you, availability, security, and protection is most important, right? Availability is in when the service goes down, how fast is it available? That is important. Security is who is protecting, is anybody intrusion, all that stuff is very important to from access privileges and all that stuff. Protection is encryption at rest, and as well as encryption in transit is important. So what KubeSlice does is it reduces the surface area inside a cluster. So that way it actually gives you the security which is needed in order to protect it. And also KubeSlice has a controller-driven model, and as well as the work fleet of clusters. So it disables all the config drift problems which are there, right? So if somebody goes and then makes some changes, some cluster, automatically the operator looks at it and says, source of truth is something else, and then this is something else, so it goes changes. So from a regulation standpoint, it helps SOC 2 compliance. It helps making sure that your collateral damage doesn't exist. It also helps with respect to chatty neighbor problem, so that you don't have any kind of starvation issues and stuff like that. And as well as it helps the RBAC functionality across multi-cluster. So the question which you always ask is, hey, Prasad, you have access to US East. Tomorrow I spin up a cluster in US West. Do I have, Prasad, the same privileges? And do I have the same Prasad there? That is a bigger challenge, because when you're in a rush trying to do something and you forget a lot of different things, you have to automate all that, whether it is through Terraform or GitOps and all that stuff. But KubeSlice maintains all that so that you don't have to do all of that.
And when I was in my previous role, I did a lot of work with the Canadian market, which is actually a pretty hot Kubernetes market. And in some of my conversations up there, I had learned that many of my customers were looking to basically have a secondary region to replicate to. And this would be an easy way to get that done. Because quite simply, it creates a point-to-point network between those two namespaces. And as Prasad had pointed out, it's a non-routable address. It's a 192 network. It has its own DNS. And it's encrypted. So there's no way for anyone outside of those namespaces to get access to that data. So it is secure and a easier way for you to replicate your data to another region. Let's see, what kind of ongoing maintenance or management is required using KubeSlice for DR? Are there automated processes for self-healing mechanisms in place?
Yeah, look, that's the reason why we used the operator model. There are a whole bunch of reconcilers which are maintained inside the KubeSlice to make sure that if anything happens, it puts back into the state which was supposed to be. So that's the reason why we prescribe that controller is a different cluster to the fleet of clusters. I mean, even if you go and then see Kubernetes architecture, etcd schedulers and all that stuff are separate from your fleet of worker clusters which you have. The same paradigm is maintained in KubeSlice to separate out the control plane for all the slice lifecycle management and the semantics associated with it. And the reconcilers inside the worker cluster maintain the state of self-healing with respect to if there is any challenges out there, right? So that's the pattern which we have used, which is thankfully Kubernetes gives you that ability to do that. Previously, it used to be a lot of work for us, but Kubernetes had made it so simple for us to put the operator model in, and then that operator model is what we use.
There was another question on there that asked, are we on the CNCF, are we KubeSlice a CNCF project?
Is KubeSlice a CNCF project? Yeah, yes, we are going to put it into Sandbox. We haven't yet done that. We are ready to get there.
But we are an existing member, and I believe we probably should have that submitted by the next KubeCon in Chicago.
Yeah, that's our goal.
Are there any specific deployment models or architectures that organizations should consider when implementing KubeSlice for Kubernetes disaster recovery?
Nothing in particular. In general, the deployment models are the DR solutions are all, people tend to say that availability zone is a disaster recovery zone. Right? If you spread across multiple availability zones, it is good enough. It is not, right? So it does protect certain challenges. Let's say that just recently, is it June 13th or June 10 days ago or 15 days ago, AWS had challenges on US East. My previous company, their whole Kubernetes cluster was affected. Now, what is the challenge? If you look at the status page of them, we were down, right? We were trying to make sure that across region, but AWS West region didn't have any problem. If I had a cluster in there and then declare a disaster, I would have been happier not answering questions of to my end customer saying that why the hell the service was down.
So this means that if you're in either if you're in multiple regions, that you can assure that if one of those regions go down, you should be able to keep your data integrity and your application up. What is also interesting is I remember, I think it was Q4 of 2021. I know it was a while ago in the world of Kubernetes, but AWS went down 3 times that quarter, and Azure went down that quarter, I think, at least once, as well as Google. So there is the idea that our clouds don't ever break. That's not entirely true.
Yeah.
And with KubeSlice, you could run your multi-cloud, a multi-cloud solution in that heterogeneous fashion. And then if AWS goes down, because we know that 80% of the people are in AWS, then you'll be able to recover in Azure or in Google or on-prem and on your data center. So there's a lot of different options there.
I think that people should not forget BGP. So I don't know if you all are networking or not. BGP is a protocol of all things, and it does reroute things in different locations, and then people can go black hole for a long time. So yeah. So yeah, what kind of monitoring alerting capabilities at KubeSlice are to help? So we have built in. So look, our pedigree is operations. We have built in all the metrics which are needed for visibility. So there is no point. I kind of built a lot of startups before. Lights blinking, bits are flowing is good enough, but if you don't have insight, the RCA, which you need to have, is very critical, right? So it is important to have. We have integrations into Slack. We have integrations into different places. We have all the events which are there. We have a whole bunch of logs which you can put in. So there are lots of ways to go look at it into everything proactively and reactively.
And as well as integration with Prometheus. So you'd be able to pull all that data, and if you're running off of your own Prometheus server, you'd be able to set up alerts based on that data being pulled in.
Yeah. Does KubeSlice work on bare metal Kubernetes cluster? Absolutely. So it has no bearing on what distribution and what. In fact, one of our customer is a gaming customer who is running all the KubeSlice on they are bridging a bare metal to a VM environment. When they on spikes, they are going to VM environment, but in a steady state, they're actually using bare metal. So KubeSlice have that connectivity across different clusters, and then be able to support all that functionality which we have.
Can you explain the underlying principles or technologies behind KubeSlice that make it effective in minimizing downtime and data loss?
So KubeSlice by in itself, right, gives you a platform to create a virtual cluster across multi-region. Think about it this way, right? If you are in a cluster and then one of the node goes down in your cluster, right? Scheduler goes and then figures out how to deploy those pods in different capacity in different nodes. Similarly, if a cluster, one end of the cluster goes down because it's a virtual cluster, you can move the workloads into the other cluster because the other cluster may have the capacity. So that philosophy of having to spread as a virtual cluster, number one. Number two is, what is a virtual cluster? Definition of networking in Kubernetes. Every pod to other pod should be talking to each other without NAT functionality. That's the foundation for Kubernetes. So we built an overlay network across multi-cluster so that if you have a cluster have a problem, other cluster is available, but services doesn't have to go through any NATs or anything. So it literally gives you the same feel that as though you have one node going down in a cluster, and the scheduler actually automatically schedules the pods in another set of nodes. So that's the kind of philosophy we have used across multi-cluster region. That way you can do PVC replication or PV replications or even the workload deployment. Very important how frequently. That's a very, very important. By the way, SOC 2 mandates that the auditors ask you, not DR should also be exercised every year. The test has to happen to get an attestation. So it is necessary to do that. Now, backups must be performed based on the business need, right? So the critical, the business, it is important to perform snapshot as fast as possible, right? By the way, after you perform a backup, don't be happy. Try to recover and see if it actually works, right? So many times I have run into a problem. Hey, backup is there. But when we try to recover, shit, that doesn't work because the data is corrupted. So it is important. This is like a regular hygiene. You wake up in the morning and brush your teeth. You don't think twice, right? So backup should be just like that. Sorry, Matt, you're on mute.
Yeah, so back to that original example that I spoke about when the air traffic control system was down. They didn't practice recovery. And as a result, I was stuck in Toronto for another half day, as well as millions of other US or North American travelers were not able to get home. They stopped flying. It was the first time that we've seen clear skies since 9/11. Right. It was that. So how important is it that you practice your recovery? It is imperative. If you don't practice it, you're not going to know what you're doing at that time.
Yeah. So,
another great question I saw was, does VPC come into this picture?
Yeah.
Do you need to make those changes? What about other infrastructure changes required to be provisioned other than Kubernetes?
It's very, very, very important question. Thanks for asking that, Sajo. Our philosophy is making sure that it is Kubernetes native. In fact, I wish I had a slide to show, but if I can show quickly, I'll show it, but we don't have time. So we bring software-defined networking inside Kubernetes cluster. So you don't have to do VPC peering. You don't have to worry about all you need to do is when you define an infrastructure, you define your CIDR pod, services CIDR, pod CIDR, and your networking. That is by default there when you bring up your clusters. That is it, right? The overlay network takes care of across clusters. You don't have to do any kind of VPC peering and all that stuff. We establish the tunnels. So the tunnels can be either through a public interface, or you want to have a private interface going across the different VPCs. That is it. And then we enable it from inside the cluster to the other end of the cluster, but not outside. So it gives you two benefits, right? Number one, from your security perimeter standpoint, you're inside the same security perimeter. You're not going through changing infrastructure from Kubernetes outside the cluster going into cloud provided services, and then you have to have a different set of keys to go and encrypt it, or you have to go to your CISOs and say, hey, do I have permission to go and then see all the data flowing through different places? All that is taken away because we are natively inside the Kubernetes cluster.
What are the future plans and roadmaps for KubeSlice? Are there any upcoming features or enhancements that users can look forward to?
Oh, there are many things which we are planning on doing in a roadmap standpoint. Right. Currently, what we have is a construct of slice. Right. We are also thinking of different things like prioritization inside it and all that. Right. Did I? lose everybody?
No, I just highlighted you.
Oh,
Yeah.
sorry. So yeah, there are many use cases where there is a secure slice, there is a data slice, there's different types of personas of different slice we are going to improve. As you know, think about it this way: you have iPhone, and then you have a set of apps, and then an app store, right? So iPhone is the foundation for you to build apps on. So KubeSlice is the foundation which we have built, and then you can build different apps on this multi-cluster scenarios. Apps are infrastructure centric apps, be it resiliency app, be it secure app, right? Now that PSP is deprecated in 1.26. Now PSS is built into it, and then part security and part admission control are built in. So how do you make sure that these set of namespaces, which are very critical for your compliance standpoint, be secure, right? So that will be the secure app, secure slice, which you're going to build on top of. Likewise, there are many functionalities we are thinking of.
Kunal, you have a fantastic community here. I have to give you the questions that we've got today are they're very well put and very well thought out. So thank you very much for having us today.
Yeah, some nice live questions, and for folks who registered for the webinars, they were able to share some nice questions which you just answered. But there are plenty more that we did not go through. For that, I want to share that I've updated the description with the Slack channel. So you can join the Slack channel and you can talk to Prasad and Matt over there. And yeah, join the community over there and keep the conversation going. I know some people reached out to me, as so I'll connect them with Prasad via email because weekend is here now, so maybe Monday. But yeah, we answered all the questions and getting some nice feedback. Thanks, Alex. Really appreciate it. This is being recorded, so you can watch it again if you want. And yeah, we'll be doing more such sessions and stuff.
I'm not embarrassed in saying this. I was so impressed with Kunal. For the last 2 years, I've been following him. Right, he is dedicated. He is a guy who is helping the community, and I really thank you for what you're doing, Kunal.
Yeah, I really appreciate it. It's all team effort. I think wouldn't be possible without having you folks, on the stream sharing your knowledge, because you have so much experience. So yeah, I mean, data recovery, data on Kubernetes is definitely a very important topic. I've spoken at, I don't know if you know, the data on Kubernetes meetups.
Yep.
So I did a session on stateful versus stateless, and it definitely gave me new points to think about when talking about recovery of data. So I learned a lot as well. Yeah, I mean, it was really fun, and this was the first one that we did live. Trying to do many more, and hopefully at some in-person meetups soon. Now that I'm not traveling till September, so we'll plan some nice things.
So I do know that the Avesha team will be sponsoring there's a there's a Kubernetes meetup that will be at the Google building in Cambridge, Massachusetts. That's basically a part of the Boston area. And of course, we will be at KubeCon in Chicago. And if you need more information, please go to our website, avesha.io or aveshasystems.com. Either one will get you there. And please reach out. I know there was a joke about Joey from Friends. It's funny.
Probably.
I don't remember my name, but you can find me up on LinkedIn. I happen to be from the same town. I went to school in the neighborhood that the actor grew up. We're not related. It's just a funny coincidence.
Oh, I definitely spoke to you in North America.
You remember that story, huh?
I remember the story. You did speak, yeah.
Yeah. Also, we have a KubeSlice channel in Kubernetes group or organization. We are also there. Just ping us anytime, anyway.
Yeah, and all the links are in the description, the website and the Slack channel. So yeah, cool. That's a good one.
Joey doesn't share food, but shares amazing knowledge.
That's It's a
Thank you, Nimesh.
friend's reference right there. Cool. All right. Well, thanks for joining, everyone, and see you in the next one. Have a good
Thank you
day.
very much.
Bye.
Thank you. Bye-bye.